All right, so I think we're recording now, but welcome to then Recitation. My name is Ivan Lee. I am the TA for Davi Maximo's Math 240 class. So if you're not in Math 240 or if you don't have Davi, you're in the wrong recitation, but you're still welcome to sit in anyways. And yeah, so a little bit about myself. I'm not going to talk too much. We'll get back to me later. But I am a senior. This is my 5th semester TAing here at Penn for the math department. And yeah, I guess I'm a math major, so I really enjoy doing this. It's a lot of fun. And so let's go around the room then, and I'll have you guys introduce yourselves. Nothing too much, but what we're going to have is I want to hear your name, your year, and why you're taking this class, okay? And so for the reason why, like, I don't care if you give me like the most generic answer, like, oh, I need this for my math minor, or oh, I'm taking this as a requirement. I actually expect that. If you say something along the lines of like, oh, I really enjoy math and I really want to learn, I'm just going to assume you're full of shit. So, yeah, so without further ado, let's start here. Again, name, year, and why you're taking this class.
I'm Veronica. I'm a sophomore, and I'm just taking it because it's a requirement.
I'm Jaden. I'm a sophomore, and I'm taking it because a cis professor recommended it.
I'm Fernando. I'm an exchange student, and I'm taking it because we didn't have linear algebra back in school.
I'm Brian. I'm a freshman. I'm taking it for my major.
I'm Fred. I'm a sophomore, taking it for Econ 101.
I'm Kai. I'm a sophomore. I'm taking it because I think it's really useful for what I want to do.
I'm Pablo. I'm a sophomore, and I'm taking it for my physics major.
I'm Augustine. I'm a freshman, and I'm taking it because it's a requirement.
I'm Kento. I'm a sophomore. I'm taking it because of computer science requirement.
I'm Grace. I'm a sophomore. I'm taking it as a requirement.
I'm Jake. I'm a sophomore. I'm taking it because I'm a physics major.
I'm Kalista, and I'm a freshman. I'm taking it as a requirement.
I'm Nick. I'm a sophomore. I'm taking it because it's required.
I'm David. I'm a sophomore. I'm taking it for a major requirement.
I'm Jerry. I'm a sophomore, and I'm also taking it because it's required.
Okay.
I'm Mark. I'm a sophomore, and I'm taking it because I need it for my major.
And
Hi there. I'm Nathan. I'm a sophomore, and I'm taking this for a general requirement.
Okay, great. So as you guys can see, first of all, like 90% of you guys are sophomores, and another thing is that like 90% of you guys are taking it because it's like a requirement of some sort. So yeah, what am I going to say? I don't remember what I was going to say. But anyways, for those of you guys that are sophomores, have you guys taken like another math class here at Penn before? Okay. And so let's take a poll then. I want you guys to characterize your last experience with your math class at Penn, all right, for you sophomores. So how many of you guys would say you guys had an absolutely great experience? It was a wonderful time. You enjoyed everything about that math class. Oh, okay. A few people. All right, good. The last recitation, no one raised their hand for that. So how about, run-of-the-mill, whatever experience? All right, that's most of the class. How many of you guys would say it was awful, professor sucked, the TA has no idea what he's doing? All right, I don't know if this is the 9 a.m. section, so you guys got to wake up an hour later, but you guys are a lot more optimistic than that previous class. So, yeah, well, hopefully, for those of you guys that had, math experience with the class, hopefully we can change that. So, Davi, so the math department then, and I'm guessing most of you guys took like 114 and 104. As freshmen or whatnot, they usually like put 85-year-olds teaching these classes who like can't string complete sentences together, or they put like postdocs who need to find a job within 2 years, otherwise they're going to be homeless. So these are the two people that usually teach your classes, and that's not a great thing because teaching isn't in their best interest at that point in time. And so, you get these very average, very subpar classes. Luckily for you guys this semester, Davi's neither one of those, okay? He's not 85 years old, and he's not a postdoc. And from what I've talked to with him, he actually cares a lot about teaching. He's a very approachable guy. He's actually I'm a math major, so he's my, what do we call it? Call him an advisor. So he's my advisor. He's very approachable. You can just go up, talk to him about whatever. Really cool dude. Yeah, and he has pretty decent reviews. And everyone who has had him for a math class have only spoken highly about him. So that's good. Me, on the other hand, I'm just your run-of-the-mill math TA. I'm just going to do what I do, hold recitations and whatnot, and I'll try my best for you guys. So, all right. So expectations for this class, I have two expectations. The first expectation is to have fun, which really doesn't resonate well with students usually in a math class, because it's like, oh, let's grind integrals for days, and no one really finds that really fun. But however, we are taking a linear algebra and differential equations class, which is a little different from your run-of-the-mill calculus classes, because we really won't see an integral until 5 chapters into this class. So yeah, that's really cool. And another thing is that linear algebra has a lot of applications just outside of whatever the hell we're doing right now. It's used in physics, math. Of course, it's used in math. It's used in physics, computer science, economics, and whatever. I personally have taken a lot of econ classes, so I've definitely seen firsthand the application of linear algebra there. And yeah, differential equations likewise. You'll see a lot of differential equations like finance, for example. So a lot of applications, and I'll try to incorporate some of these applications into the recitations as we move along the semester, just so you guys can see that, hey, a world exists outside of Math 240 for these things we're learning, and I guess that should make the class a little more fun, or hopefully that will make the class a little more fun. What else? Second expectation then is, so I'm gonna preface this by saying that Davi, when I've talked to him, he says that he wants to be like a coach for you guys. So he's not really out to get you guys, but he really wants you guys to perform your best. All right. So he's gonna be tough on you. There's gonna be some tough love. And if Davi's the coach, then I guess I'm the quarterback of the team, or I'm I don't know, the captain or something. Whatever. But in any case, I'm on your side. I'm definitely not out to get you. My job is to grade your homeworks, but I'm not trying to take as many points off on your homeworks as I can. And you see that I grade pretty leniently, and we'll skirt around the homework rules just a little bit, but this is on recording, but pretend I never said that. So yeah, feel free to approach me with any questions you may have. I'm an undergrad. I've sat in this class. I took this class. You'll have undergrads who are the super duper smart math kids who have never taken Math 240 before, and so they can't connect with the struggles that you guys are going through. I personally have sat in lecture with a certain professor that you guys might have heard of who starts sentences, stops them, and we're just left there thinking, what the fuck is he trying to teach us? And so I've been through all this. Believe me, I know your struggles, and so feel free to contact me with any problems you may have, whether it be inside the course, even outside the course. I'm down to answer anything you might have. All right. So again, don't think of me as some authority figure. I hate I don't like that kind of connotation associated with me. So let's transition then, I guess, into a little bit about myself. So like I said, I'm Ivan. I'm actually the highest rated Math 114 TA ever on Penn Course Review. So if you look at Math 114, and let's see, if you go to this plus sign and you look at TA quality and you sort, this is me right here. I taught for Marcy Havlicek in the spring of 2017. I more or less, I thought I was going to be TAing Math 114. So to your guys' I guess benefit, I'm your guys' TA this semester. I actually did TA Math 240 last semester, and once Penn Course Review updates for that, I'm going to be the second highest Math 240 TA ever, rated on Penn Course Review. And the other guy that's above me had 17 students, so that doesn't count because that's having one recitation. So as you can see, I think I do a good job of teaching recitation. You might think I'm overrated, and whatever. If you think I'm overrated, you can let that be heard at the end of the semester. But what makes me get these like good reviews from students? Here, Ryan can attest to this. Hi, Ryan.
Hi.
And but anyways, so one thing I have is I just have a ton of resources for my students. So if you go to my website up there, ivanlee.com, and it's linked in the syllabus, or ivan-lee.com, you'll see this brings you to my homepage. Brand new and updated for fall of 2018. And on this teaching tab here, under Math 240, you want to go to homepage, you'll see that I have a shit ton of resources for my students. So let's talk about, first of all, the newest thing for this semester, which I call the Plug and Chug series videos. And so what I did was, based on feedback from last semester, one thing that students seemed to really struggle with was just run-of-the-mill homework problems. We were like, hey, why can't I solve this homework problem? Well, maybe it's because you've never seen an example like it before, right? So what I did was then go through each section of the book, and I went through, just really general concepts, and I did an example problem of usually textbook problems from that section. So if you look at change of basis 4.7, you'll see that it's hooked up to my computer, so I can actually write on my computer screen, which is what I'll do when we get to the material. But let's load. I thought Penn had good internet. Okay, yeah, as you can see here, I'm just doing a problem straight from the textbook. What is that, 4.7.21? And so you guys can watch these at your own pace, at your own leisure. The point of these videos was to help with homework problems, and more so with the mechanics of the homework problems. I'm not going to talk about any theory behind these problems. It's more just how the hell do I set up this problem and how do I grind out the correct answer. That's why it's called the Plug and Chug series. We're just plugging shit in and we're getting answers out. That's on those videos. Okay, so there's a bunch of these videos. They're all linked on my website. There's a YouTube playlist for them as well. You can see the notes to the series. I have my OneNote Notebook. And yeah, for every section in this class, there's a video. I also did the same thing for Math 114 because, again, I thought I was teaching Math 114. But so if you have friends in 114, you can let them know as well. But yeah, so here are the videos. So that's the big thing that's new, and hopefully they'll be really helpful. The other big thing that's new and that's going on right now is that I'm actually recording this recitation. So yeah, as you can see, hopefully this is recording. It says it is. And after I'm done with this recitation, I'll go and I'll upload it online, okay? And so you guys can then go back and just watch the recitation if you want to, and go over some of the material that we went through in recitation, okay? And I'll also upload the written notes from the OneNote Notebook that we will be covering today. All right? Great. So what else is here? Let's see. We'll cover course administrative stuff a little later. So there's some miscellaneous resources here. There's a book of Math 240 notes that I started, and I was just too lazy to finish. So for those of you that were in 114, you might know of my 114 notes. This is nowhere near as polished as that. I mean, this is just completely unfinished. What else is there? I wrote up full solutions to previous finals. And so you can see that here I actually just did all the finals problems. And so there are 6 finals that have full solutions to them. However, I don't think you guys will be using these too much because I will be stealing a lot of previous finals problems for recitation. And the reason is because last semester, our professor put previous finals problems on their homeworks, right? And just early exposure and more often exposure to previous finals problems will allow you guys to really adjust to the difficulty of the final, throughout the semester, rather than just getting smacked in the face with what the fuck is this at the end. So yeah, so we're gonna be covering a lot of finals problems, and that class last semester we killed the final. I don't know if you guys know how we curve Math 240, but other classes had the standard 30-40-30 curve. We had 70% A's and 30% B's. and nothing below that. So like that's like unheard of for a class, and it's because we saw finals problems early and often, and that's what I'm going to do then with recitation, is that we're going to push finals problems on you guys early and often. So hopefully you guys don't have to resort to this during the final. How you guys will study for the final then, we'll get to that as the final approaches, but it's more along the lines of you want to go over previous midterms and other professors' midterms is probably the better way to do it, okay? All right, so that's that for the previous exam solutions. Then we have old videos. So I actually have even more videos online, but these are made from last semester when actually still used chalkboard and chalk. And they go a little bit more into the theoretical details of chapter 4, as you guys can see, which talks about vectors and vector spaces. That chapter is going to be easily the most abstract, like, math concept you guys will ever take, unless you go on and take, 370 or 502. Like, a lot of students get confused. So there's more resources for the chapter 4 stuff. They're there, just to let you guys know. And yeah, that's about it. And then we got some prerequisites. Really, you don't actually need to know multi for this class. Like I said, we don't take an integral until like chapter 8. So you don't need to know that. You do need to be comfortable with doing like arithmetic and algebra quickly and like taking derivatives, because that's what all differential equations is that we're taking derivatives for days. So get used to that, I guess. And yeah, complex numbers, whatever, stuff you guys should already have seen before. Okay, any questions so far? Great. So okay, so now we're going to cover even more administrative stuff. I know. So did any of you guys like switch into this class like either yesterday or like? Okay, you did?
Yeah, I'm not supposed to be here, but I'm here.
Oh, okay. Hi. So, yeah. So I guess Davi should have covered all this already, but again, really quickly, because I have a little part I need to cover. We have 3 exams and a final, right? And the 3 midterms, one of them gets dropped, okay? So then the weights are going to be 20% for each midterm and 40% for the final, all right? And because a midterm gets dropped, apparently you're not allowed makeups, all right? And because we are the Penn Math department and you're not allowed makeups, we schedule the first midterm on a Jewish holiday. So if that is a problem for you, I can't do anything. You're going to have to let Davi know. And we've already had a handful of students like complain about this. Okay, we'll see what we can do. Anyways, 1 drop, no makeup. Homework due Tuesday. So does anyone know what September 11th is? It's a very ominous day, right? Your first homework is due. So yeah, your homework's due on Tuesday. And because of that, you'll see my office hours here then. I try to schedule them around the homeworks as much as I can. So you got Friday, 1:30 to 3. We got Monday, 1:30 to 3, which I'm guessing is going to be super busy because y'all are going to start the homework until Monday morning or Tuesday morning. But then I can't help you on Tuesday morning. So, and I got Wednesday after the Wednesday 9 a.m. recitation. Okay, so I have 5 office hours. Your average TA is going to have like 2. So like take advantage of that. And also 3W8, that's my office. I share that office with a bunch of TAs, and they're all undergrads and they're all super smart. So if you're just like in DRL and you really need math help, like you can just stop by that office. Someone's going to be in there, and they're they're going to be very likely willing to help you guys with anything. And I might just be in there randomly. And if you see me in there, you can stop by, say hi, or like ask me a problem. That's fine. Okay. Cool. So that's that. So we got through 100% of the grade, and yeah, and again, there's no lates on homeworks, and you get a drop at least like one of them. I think you get 2 drops.
Yeah, I think it's 2.
It's 2? Okay. In that case, I might be a little less lenient to take your late homeworks if you get 2 drops instead of 1. But if you come up with a good excuse, that's like my dog ate my homework, then I will take it late usually. But Let's try to keep that to a minimum. Okay. And all right. Okay. So Davi probably mentioned in class then that there's like 2% extra credit, right? And I get to hand out 2% extra credit, which does nothing to your grade except we look at edge cases at the end of the semester. And the way I'm going to do extra credit, unfortunately for you guys, is that it's going to be on Piazza participation. All right. So on my website, I have a link to Piazza. Is everyone familiar with Piazza here? Okay. If you're not, all you have to do is you just need to sign up. And what Piazza is then is it's like a bulletin board of like just questions you can ask, and you can ask them anonymously to your classmates. All right. So you don't have to have your name shown to your classmates. I have to see your name because I need to give you guys grades for the Piazza participation. So yeah, so that much is there. And you know, the reason why I like to use Piazza, there are a few reasons. Firstly, I can, you know, type mathematical notation into Piazza, right? I can easily create matrices, while on like email, I have to do like 7 space space, -5 space space, 2 enter, and then do that all over again. That's a pain in the ass. So if you have any like homework problems, especially, like just ask it on Piazza. Again, there's going to be some weighted average of like good questions, good answers, and just overall just like posts on the page, and so you can get extra credit that way. All right. And okay, yeah, and I said there were multiple reasons why I like to use Piazza. So the second reason is because down here at least, you'll see that there's an average response time. Okay, so for you guys, what that means is that I'm actually pressured into answering your questions quickly because I don't want to see that average response time at like 7 hours. All right, which, believe it or not, actually happens in a few classes. I usually keep that to around 10 minutes. I try to answer your questions within 10 minutes, usually faster than that. The only time you're not going to get an answer quicker than 10 minutes is if you ask it at like 12, because I'm usually asleep by then. Okay, so I go to bed pretty early. But if you ask it like late in the evening, you're not going to get an answer until the morning. But usually throughout the day, I'll be not listening to class and on my laptop, and so I'll be able to answer your questions like pretty quickly. Okay, so that's that. You can also send me private messages on Piazza. So if you like, so even if like the anonymity is like not enough for you, you can just directly send a private message to me, and I'll be happy to answer those as well. Try to keep like administrative and maybe like personal issues off of Piazza. Just actually email those to me then, like straight to my email, if we can keep it that way, and just keep like homework, exam logistics like here. All right. Great. And that's going to be 2% of your grades. And what else? So recitation. Oh yeah. Question.
For posting or answering?
So there's like there's like total contribution, which is like total posts, like just like even questions. And then there's going to be like I can assign like good answers, and like I can see like I can consider you asked a good question or not. So those two, of course, will be weighted more heavily than just me spamming questions all day on Piazza. So, well, like it's not to discourage that because you still get points for like asking a bunch of questions. It's just that you won't get as much as if you asked a good question or if you answered a question well. So, okay. So yeah, like if at the end of the semester you're posting, can I bring a pencil to the exam? Just know that that's not going to affect your grade that much. Okay. What else? All right, recitations. There are 4 of them. You guys are in the last one. This one gets recorded. I have 2 of them on Wednesday. There's one at 8 a.m. So if you really want to, you can come to the 8 a.m. ones. The caveat is that I did tell the 8 a.m. kids that they could come to the 9 a.m. recitations, but I'll force them to sit on the ground if they're not registered for the section. So you guys will be fine if you want to show up here. If you want to show up Wednesday, that's fine. Just note that there is a room change for Wednesday. Okay, we're in a different room. It's down the hall here to your left. And if you want to show up to 8 a.m., hey, be my guest. There's going to be a lot fewer people in the 8 a.m. sections. So, you know, if you want the highly advertised student to faculty ratio that Penn has show up earlier, I guess. Okay. Or the other option is, hey, you know what? Fuck me. You guys don't show up. You guys can just not show up. I don't give a shit. Yeah, I honestly don't care if you guys show up or not. Like, I am recording this, so if you guys don't want to show up, fine. Just know that at the end of the semester, if you're a borderline case, and I'm like, I've never seen your face in recitation, there's no way I'm bumping you up to that A-, okay? So that's not gonna happen. So if you want that, I guess show up to recitation. But hey, who am I to tell you guys what to do? So, any more questions? We're gonna actually get onto material now. Great. So again, website's on the board. It's also on the syllabus. And alrighty, let's begin. So first day, I'm not going to do much. We're going to have more of like a thought exercise, and we're going to try to visualize like what's going on with linear algebra, or more specifically, what's going on with systems of equations. So even before we jump into that, we're gonna discuss some notation, because I know one thing that students get lost on is, hey, if you don't understand what my backwards E is, you're not going to understand what the hell I'm talking about in that problem. So let's talk about notation. And I'm just going to throw a bunch of symbols at you guys. So this first symbol is going to be the upside down A. All right. And what does that mean? This means for every. Okay. And then I got the backwards E. It means there exists. All right. What else? I got 3 dots in the form of a triangle. And that's going to be therefore. And let's see. And then I have some just words I like to abbreviate. I abbreviate a lot of words, and so these are going to be the most common. ST is going to be such that. And MX is going to be matrix. So as you can tell, my handwriting is like pretty bad, and so in order to like save your guys' eyes, I'm going to try to write less, and so I'm going to abbreviate a lot of stuff, okay? What else? A lot of this is, I'm trying to recall off the top of my head. Okay, so there's this E. It's like a euro. Well, not really. And this is going to be an element of. So sometimes you'll get set notation that looks like the following. Okay, and so you'll get like, 3, 4 is an element of the set x, y such that x plus y is equal to 7. All right, so what the heck does this mean? This is going to be an element. All right, this is an element. And then this is in, right, or an element of. And then this x, y here is just your generic element in the set. That's the other abbreviation. Okay. So element is ELT. So, okay, so your generic element in the set is going to be a tuple, right? It's going to have x, y. And the condition, so this is like, so this circle here, these 2 dotted points here, this is going to be like such that. This could also be just a straight line instead of 2 dots. Okay, so those are the same thing. Okay, so in this set, I have a tuple that satisfies the condition x plus y is equal to 7. So this is going to be the condition. L must satisfy. All right. So as we can see then, 3, 4 satisfies the condition that the first element plus the second element is equal to 7, right? And so, all right, that's why this is going to be in the set. Okay? And I'll try to refrain from using too much set notation, but the reason why I'm introducing it is because you'll see problems that are just introduced like this. So I don't want you guys to be like, I can't do this homework because I just don't know how to read what the problem's asking me. Okay? All right, is that it? Is that it? Nope. We got more. R. All right, what is R?
All real numbers.
All real numbers. All right. It's also like a pirate's favorite word to say, but we'll stick with all real numbers for now. So what is a real number? E.g., examples, I don't know, root 17, 25, 4/3. Those are all real numbers. Okay, and with R, we have its cousin, or big brother, C. And what's C? Anyone? It's going to be complex numbers. All right, C is going to be the complex numbers. And so, for example, what do we have? Well, okay, so a complex number looks like A plus BI, right? So A and B are going to be some just scalars. And so we can have like 2 plus 5i, or like 2 minus 5i. That's going to be a complex number. What else? You can have just negative 4i. That's going to be a complex number. What else is a complex number? Pi is a complex number. Why is pi a complex number? Yeah. It's irrational, okay. Yeah.
So when b is equal to 0?
B is equal to 0. That was more of the answer I was looking for. So yeah, so A plus BI, there's nothing saying that B can't be 0, right? So if B is 0 and A is pi, then hey, we got a complex number. So what does that mean? Well, just really quickly then, that means that all the real numbers are going to be contained in the complex numbers. So this just means contained. So that's like a lazy way to write it, but you know, that is how you can also write it. So this C symbol really should look like that. Means contained. And I mean, there's like strictly contained in, whatever. I'm not going to get too technical with you guys. So, all right. And now one last thing. Promise we'll move on. Rn. Okay. So now you got R with an N on top, and this is going to be n-dimensional space. Okay. And you can think of real numbers because we're in Rn. So, for example, what is R2? It's two-dimensional, yep. And how do we usually characterize two-dimensional areas? Yeah, xy plane, right? So R2 is going to be a two-dimensional space. And so I'm not actually going to say xy plane a lot in this class. I'm just going to say R2, okay? And then we also have R3, which is three-dimensional space, okay? Those are going to be usually the spaces we're operating in, but don't be surprised to see like R7 or R4. They'll show up. All right. So now let's finally jump into material for today. And what are we talking about today? Well, we're going to talk about intersection of lines and planes. And for those of you guys that want, this is actually Math 114, section 12.5. And why are we doing this? Well, essentially, because not too much material has been covered, I want you guys to be able to visualize like why, or the intuition behind why we're setting up problems a certain way. And so let's consider then first 2 lines in R2. All right, so how many ways can 2 lines in R2 intersect?
2.
1, 2, 3, 4, 5? 2. 2 ways? All right, what are the 2 ways they can intersect? At a point, okay. Got one last way.
That's mine.
Yeah, they're the same line, right? So everywhere. All right. They can also just completely miss each other, right? So nowhere. And that's going to be if they're parallel. Okay, so let's take a look then. Let's take a look at an example then where they intersect at a point. So let's do this. Example at a point. So let's take the following lines. I don't know, x plus y is equal to 5. X minus y is equal to 3. Okay, and so we'll have our xy plane. What does x plus y equals 5 looks like? This is going to be a really rough sketch, but it's going to look something like that, right? X plus y is equal to 5. And then what is x minus y is equal to 3? Well, that's the same thing as y is equal to x minus 3. So we're going to get something like that. Oops. And they're going to intersect at a point. And what is that point? Is it 4, 1? Okay, so this is how we do. This is how we set up a system of equations, right? So these, we have 2 equations and they'll intersect at a point. And so I'm going to jump a little bit ahead of Davi here, but essentially, how do we express then this system of equations in terms of matrices? All right. So you guys got through multiplication yesterday, right? Okay. So then let's consider the following. Let's just take the coefficients in front of these guys, and we're going to toss them into a matrix. All right. And the matrix is going to be 2 by 2. All right. And the way we read this is we actually read it 2 by 2, as in like we read the number of rows first and then the number of columns, which is kind of counterintuitive when you see it initially. All right, and so what am I going to do? How am I going to copy the coefficients? Well, essentially, I'm just going to look at, okay, what's the coefficient in front of x? 1, right? So then that's going to go here. All right. What's the coefficient in front of y? 1. That's going to go here. Okay. Well, what's the coefficient in front of this x? 1. And what's the coefficient in front of this y? -1. All right. Are we following that?
Yeah.
Okay. And then, so why can we do that? Well, because if we actually just write xy here, if we multiply it by this 2 by 1 column vector xy, let's multiply this out. What do we get? Well, we get this row times this column, which is x plus y. All right, so we get x plus y. Again, that's this guy times this guy will give you the x, and then this guy times this guy will give you the y. And then we'll multiply this guy with x. Let's use a different color, green. So this guy with x, and I'll get x, and then this guy with y, and get -y. Right. So you see that this matrix here is completely representative of this guy up here. All right, these two are the same thing. Okay, but we don't really want x plus y and x minus y here on the right-hand side, right? What do we want instead?
Numbers.
Yeah, we want numbers, right? Because we know what x plus y needs to be equal to. So what does this need to be equal to? 5. And what should x minus y be? 3, right? Okay, and this is how we set up a system of equations. And so how do we solve this then? Well, come next week, we're going to see how we find x and y in this system. Okay, but this is just a setup. All right. Any questions? All right, let's then consider. Let's jump over then to 2 lines in R3. So, how can 2 lines intersect in R3? Yeah. Okay, at a point. In a line. All right, so they can intersect everywhere. Right, if they're the same line. And nowhere if they're parallel or skew. Okay. What's the equation of a line in R3? Yeah.
Parametric.
Yeah, it's parametric, right? Why isn't it x plus y plus z equals something? That's a plane. All right. So in R3, just keep in mind that the equation of a line is going to be something along the lines of like r of t is equal to, I don't know, a naught plus a1t, comma b naught plus b1t, comma c naught plus c1t. Right, where a naught, b naught, c naught, that's just a point the line passes through. And then a1, b1, c1, that's like a vector on the line. Again, this is all 114 stuff from 12.5. So if you really had to, you can go back and watch. You can actually watch the 114 videos from 12.5. Okay? And 2 lines in R3, their intersection, setting up their intersection into a system of matrices is actually going to be a little more interesting. It's not as straightforward as just copying the coefficients down. We actually have to think a little bit. So in the sake of time and the fact that we'll probably have to do it next week, we're not going to do it today. All right. Now let's consider then 3 planes in R3. No. A little ahead of myself. 2 planes in R3. Okay, so how are we going to intersect 2 planes in R3? Yeah. In a line. Any other ways? In a plane. Any other ways? Nowhere. Right, so the plane is everywhere, really, where they're the same plane. Okay? And nowhere, well, that means they're parallel planes. What about point? Can 2 planes intersect at a point? No, not really, because, I mean, even if we do something like, I guess, here's a plane, that kind of looks like they're intersecting at a point. But this is really like an infinite plane, right? It should extend forever. So it'll go into the paper and we'll get a line of intersection. So yeah, we can't intersect 2 planes in R3. We can't intersect 2 planes in R3 at a singular point. Okay, so these are only 3 cases. What about 3 planes in R3? How do we intersect 3 planes in R3? Or how can we intersect 3 planes in R3? Yeah.
3 lines?
So like concurrently.
Concurrently. Oh,
Yeah,
sorry.
yeah.
The line.
So a line. A point. A plane, right?
Two lines.
Can we intersect 3 planes in 2 lines? No, we can't, right? Because if we're going to intersect 3 planes in 2 lines, then we're going to actually get a 3rd line as well, right? If you have 2 planes. But you can't do that concurrently. So we can only do 1 line, 1 point, or a plane, and nowhere, right? They can just all miss each other. So this is going to be if they're the same planes. So I guess to demonstrate, if you think of this laptop here, right? If you think of this back as a plane and this bottom as a plane, right? So if this goes here, right? If the paper goes there, then the hinge is going to be a line, right? If we do something like this, all right, where's the intersection? Well, it's going to be the point in this corner right here, okay? And I guess they can all miss each other, or they can just not intersect like that at a single place. Okay, so here you're going to see that, well, they're not intersecting at a common place. So that's how those things intersect. All right, and 3 planes in R3, really, it's going to be the same way as we did lines in R2. Okay, so for example, you'll get like pi 1 is equal to x plus y plus z is equal to 3. Pi 2 is equal to, I don't know, 2x minus y minus z is equal to 4. And then for the 3rd plane, you'll get something like negative 2x plus y minus 3z is equal to 7. Something like that. And then the way we're going to set it up then is we're just going to copy these coefficients into some matrix. So this row goes here, 1, 1, 1. This row becomes 2, negative 1, negative 1. And then this row becomes negative 2, 1, negative 3. And then, yeah, and then multiply that by some x, y, z to get your right-hand side 3, 4, 7. And then we can solve for x, y, z. And what should x, y, z be? Well, x, y, z can be a line, right? It can be the equation of a line. It can just be a singular point. It can even be the equation of a plane, but that's not going to happen, right? Because those 3 guys are not the same plane. And they can just miss, and we can have no solution to this system of equations. Okay? And, you know, I think that's a good place to stop. So next week, then, we'll actually jump into solving these systems of equations. And I think that's about it. We'll talk about more. We'll introduce more vocabulary to talk about these systems. So, again, office hours happen today, happen Monday. I guess maybe not Monday because it's Labor Day, right? So enjoy your weekend, long weekend, and hope you guys see you guys next week. Yeah, definitely.
Ivan, I see you have a new website.
I did.
The accolades page actually killed me.
I was bored. I was like, oh man. Yeah, I just decided to practice my HTML, I guess. Yep.